Hello everyone. In this video, we are going to see replace for X question that came in CodeChef October long challenge. Let's see the question. So in the question, it is written that you are given an array of n integers from a1 to an and three more integers x, p, and k. An operation on the array is defined to be replace the kth smallest integer in the array with any integer you want. Okay, so we will be given a integer k, a position k, and we have to find the kth smallest. For example, if k is equal to 3, then we have to find third smallest integer in an array, and we have to replace with any integer that we can. It can be any integer from which we can replace. Now let's read further. Output the minimum number of operation you must perform on the array, possibly 0 operation, to make the pth smallest element of the array equal to x. It is impossible to do so. Output -1. So there will be, if we are changing kth smallest element to any integer, it will reflect on pth smallest integer. It should reflect on pth smallest in element, because ultimately our goal will be to make the pth smallest element. For example, if p is equal to 2 and k is equal to 3, let's take it from let's understand from this that, for example, k is equal to 3 and p is equal to 2, and we have sequence, suppose 1 2 3 4 5, and here, and we want suppose x is equal to 5. So here it means that we can change third smallest number. What is third smallest number here? Here 3 is third smallest number. And and what we want to make, where we want to see the change, we want to see the change in second smallest number. We want to make this number equals to x, that is 5. That second smallest number should become 5. So this is what question is saying to us, that can we make performing this operation by changing this k again and again, this k, the smallest element, again. Suppose we change it 3 to 6, we change 6 to 1 or 1 to 5, we can change it to any element. The third smallest element we can change to any integer. But after changing it, suppose if we change it to 5, suppose let's take it, we have changed this to 5. So after changing, we have to sort the array, because currently now it is not third smallest integer. When we will sort the array, then only we will get to know that what is the third smallest integer. 1 2 4 5 5. Now third smallest integer is 4. So now we can implement the change on 4. So it is not important what will be the value. We have to change only the index, that is we can only change the a of k, that is a of 3, that is third smallest number. We can only change, if we are taking an array a, then we can only change a of k. And we want to know that after changing a of k, can we get a of p equals to x? And there is possibly 0 operation. There will be some case that we do not need to perform any operation, and we are getting x. And there will be also case that there will be impossible to do so, that if we are applying the change also frequently, we are changing k and we are changing it for infinite time, but we are not getting our required answer. So this is the question, that we want to, that CodeChef has given, that we have to solve. It is possible. If it is possible, then we have to print out the minimum number of operation in which we can perform this question, do this question. Else we have to just print -1. So let's better understand with the sample case example, which is also, let's understand the sample case which is given in the question, that there is 5 4 3 4 and the output is 4 sequence is 4 9 7 0. Here n is equal to 5, x is equal to 4, p is equal to 3, and k is equal to 4. Firstly, if we have got the sequence and we want to third smallest or fourth smallest or second smallest, what the first thing is strike to our mind? First thing strikes, that is sorting, because it is nothing is better than sorting if we want to get third smallest number or second or largest number or smallest number. So we will just sort the array 0 4 7 8 9. Now this will be the array after sorting. This will be the sequence after sorting. Now where we can change, what is the fourth smallest integer here? 1 2 3 4. Fourth smallest is 8. So we can, a of 4 is equal to 8. And if we take it 1 2 3, then third smallest is 7. And what is our requirement? Our requirement is 4. So we want to make this a of 3 equals to 4. This is our requirement. This is our requirement, that this we want to do this thing. But can we do this? Let's see that. And where we can change the operation, where we can perform the operation at a of 4. So now we will, let's change a of 4 to any element. It's 8. Let's change to the number itself. Let's change this to 4. So now again we have to perform sorting. Why? Because in now you will see that it is not the fourth smallest integer. Now some else element will be fourth smallest integer. So now again if I sort it, 0, 4, 4, 7, 9. This will be the after sorting. Now what is a of 4? A of 4 is now currently is 7. Now what is a of 3? A of 3 is 4. And what was our requirement? A of 3, we wanted to make a of 3 equals to 4, and we got a of 3 equals to 4. And how many times we have changed this value? We have changed only one time this value of k. We have to perform the minimum number of operation. If we would have changed it to 6, we would have changed it to 7, then we have to perform more operation. But we have to get minimum number of operation. So in this case, we will print 1 because the answer is possible. So we print the count 1. So this was the explanation of the question. This was what the question want to us, and what is x, what is p, what is k. And now we will see the approach of this question, that how we are going to approach this question, how we are going to build the logic for this question. And now in this video, we will see these all things. Okay. So now firstly, we will see the two cases. Firstly, we will see that when will be our answer always be 0, and when will be our answer always be -1. Let's see when will be our answer always be 0. So what we want to get, that a of p will become x. The value a of p should, that is the third, if p is equal to 3, then our third smallest element should always have value that is given in x. Here it is x is equal to 5. So third smallest element should always contain 5. And if it is already third smallest element is containing the value that is same as x, then there is no need to perform any operation. Then there is no need to perform, because if the array is not sorted, we will sort the array and we will check that is a of p is equals to x. If it is a of p is equals to x without performing any operation, if the pth smallest element is equal to x, then we will print simply answer equals to 0. We will print 0 and we will check for another test case. So this was the case when answer will be always 0. Now let's see when answer will be always -1. So let's take this example, and firstly we will take this p is equal to 3, k is equal to 5, x is equal to 14. And so the array is sorted. And what is the a of 3 here? A of 3 is equal to 5. And what is a of k equals to here? A of k is equals to 13. And what we want to change, we want to make a of 3 equals to 14. We want this value to become this. So let's start performing operation. Let's start changing value of k. Let's change value of k from 13 to the value itself. Let's change it to 14. 3, 4, 5, 12, 14, 25. After performing the change, still it remains the fifth smallest element. And what is the value of a of p now? Value of a of p does not reflect any change on a of p. A of p is still remaining same. Now let's change the value of this 14 to, let's change this to 3. Now what will be our array look like when we will change the value of it to 3? Then our array will be 3, 3, 4, 5, 12, and 25. Now what is the value of a of 3? A of 3 is equal to 4. What we want a of 3 to be? We want to be 14. And what is a of k now? A of 5, that is a of 5 is 12. So we can now perform any operation. We can now change 12 to 6, 12 to 4, 12 to 5. But we will keep on performing our operation, but that will never reflect the change on third smallest element. That is, if it is reflecting, the third smallest element can never be this 14, because the third smallest number you can try with some more cases. Let's replace this 12 with let's replace it with 15, or let's replace with it again. If we want to make it 14, let's replace with it 16. So 3, 3, 4, 5, 16, 25. So you are saying that we can change it at any time, but there will be no any successful operation we cannot see performing which we can get, change the value of a of p to x. So we can observe this thing by writing 2 to 3 more cases, and we can observe this thing that whenever I'm writing here that whenever p is less than k and a of p is less than k, less than x, then our answer will be always minus 1. In this case, our answer will be always minus 1. A of p is less than x. In this case, our answer will be always minus 1. Now, when else our answer will be minus 1? Let's understand that. It was the one case. Now, let's take this case. When p is equal to 4, and I'm taking the same sequence. I'm only changing the value of p, k, and x. Now, let's take another u. A of p. Now, what will be the value of a of p? Value of a of p will be here. It will be 4. Here it will be 12. And what will be the value of a of k? Value of a of k will be 4. What we want this p to be? We want this p to be 11. We want this p to be this. We want to make this a of p to x. That is 11. Now let's perform the change on this array. Let's change this, and we change a of k. Let's change it to 12, 11, the value itself. So now what will be the sequence? 3, 4, 5, 11. Sorry, 3, 11, 5, 12, 13, 25. This will be the sequence. Now after sorting it, what we will get? 3, 5, 11, 12, 13, 25. This will be our array after sorting. So now again we will check a of p. What is a of p? A of p is a of 4. It is remaining same. It is 12. There is no reflection on this. Now again let's change the value of 5. Let's change value of 5 to 27. Let's change it to 27. Now 3, 27, 11, 12, 13, 25. 3, 11, 12, 13, 25, 27. Now again we will see that value of what is a of 4? A of 4 is 13. Again, is the value is becoming to 11, becoming equal to 11? It is not. We can perform few more operation on this, and we will check after performing few more operation. We can get the same approach, same pattern here also that we got here. That if p is less than k and k a of p is less than x, the answer will be always minus 1. Similarly, if p is greater than k and a of p is greater than x, the answer will be always minus 1. In this case also answer will be always minus 1. So we got two cases. We got two cases that when p is less than k and a of p is less than x, then answer will be minus 1. And p is greater than k and a of p is greater than x, then also will be always minus 1. So before solving this question, before going for the normal cases, we will get answer. We have to find the minimum count. So before going to that, we will check these three conditions. Firstly, we will check that is a of p is equals to x. If it is, we will print 0, and we will check for another test case. Secondly, we will check for is p is less than k and a of p is less than x. If it is so, then we will print minus 1. Thirdly, we will check, and we will check for another test case. Thirdly, we will check that is p is greater than k and a of p is greater than x. If it is so, we will print minus 1, and we will proceed further. Now what is remaining? Now only one case is remaining, that we have to find the minimum count. So now let's take those cases where we have to find minimum count. So I am taking this case, the array is sorted here. Let's take p is equal to 3. So we want a of p, that is 3, that is 20, and we want a of k, that is 40, and x is equal to 12. We want this a of p to become this x. And what is the value of a of k is equal to 40. Now, firstly, we will check this condition. Is p is less than k? Is p is less than k? Yes, 3 is less than 4. Is a of p is less than x? What is a of p? Is 20. And what is x is here? X is 12. So this condition fails. So we are here, we will get answer. The answer is possible. So now let's change the value of a of k to the number itself. To the number itself. Why I am always saying to the number itself? Because ultimately we want this number only, to 12 only. So instead of replacing with some other number, instead of replacing with some number frequently using any number for 10 or random numbers, we should replace with the same number only, because then the probability of getting the pth position equal to x will be very much high. So that's why I'm telling you that replace with the same number. Now a of k is equal to 12. Now if we replace with 12, what will be the array look like? 10, 15, 20, 12, 50, 60. Now we will sort it. 10, 12, 15, 20, 50, 60. Now what is the a of p here? A of p is 3. What is the value of a of p? A of p is 15 here. Have we got the what we want? We want it to 12. So we are not getting 12 now. We have to perform one more operation. Let's check and perform one more operation. And where we can perform? We can perform on this a of k. What is a of k currently? A of k is currently 20. Let's make it to a of k to 12 again. Let's change this to 12. Then it will be, let's say, 10, 12, 15, 12, 50, 60. Now we will sort it again. 10, 12, 12, 15, 50, 60. Now what we want? We want a of p to become x. And what is a of p currently? A of p is x here. A of p is 12 here. You can see here that a of p has become 12 here. And how many times we have performed the operation? We have performed the operation only twice. Firstly, we have performed here. Secondly, we have performed here. So what will be our answer? Our answer will be 2. Answer will be 2. That we, so firstly we will check for the cases that will give us that where it is impossible to get answer, or where answer is 0. So at checking those cases, we have avoided the edge cases. Now we will see only those cases where answer is possible. And if answer is possible, only when we will keep on replacing the value of a of k to x, a of k equals to x. We will keep on replacing the same value with a of k, and we will keep on again and again sorting. Ultimately we will get the answer. If we are, this is a brute force approach. This will pass your first subtask. Later on I will tell you the optimized approach. This is the brute force approach that will strike to our mind when we will write these cases for 1 to 2 times. When we can observe that if we are continuously changing the value of a of k and it replacing with it x, and again and again we are sorting it, and again we are checking that is a of p is equal to x now. If it is so, we will print the count, that is the updated count. If it is not so, we will simply perform it again. Now the catch is, now till when we will perform, how many times, what will be the condition in our while loop, what should be the condition in our while loop. So suppose we are using while loop, and suppose we are using a count variable, and this is storing the value is equal to 0. Suppose its int is equal to c is equal to 0, and we are going to less than n. Why we are going to less than n? Why? Just think that why we are going to less than n. Because how many times we can change the value of k? At most we can change a of k to n times, because in the worst case the pth value will be at somewhere at first element or last element, and we are changing, and again the we can see the reflection at a of k and a of p. We can see the reflection at the a of k. If we are changing a of k, again the value of a of p is getting changed. So like this, performing this operation, at most we can get to c less than n. At most we can go to c less than n. Else we can, there's no need, and we will not get -1. We will surely get this answer, because -1 cases we have dealt with here only, and that impossible cases we have dealt with here only. So what will be the inside this loop? Inside this loop will be that, firstly we will increase the count, because we have, if it is not done, we are performing the operation for one time. And what will be that? That we will change a of k to x, and we will check, we will sort the array. We will sort the array, and we will check after sorting that is a of k is, a of p is equals to x. If it is so, we will break the count, we will break the loop. If it is not so, we will simply iterate for another case, another count, another, like this we will keep on iterating, and simply we will print count afterwards. After while loop, we will print count. This C only. We will print this only. So this was the brute force approach. This was the first approach. Now, how can we observe the pattern? How can we observe this so that we can avoid this all the iteration thing, and we can just get the answer, get our answer only with the one go? There will be a formula type of thing that we can observe. So I want you to just pause the video for a few seconds and just think that whether we can get the optimal approach with using this pattern by, because it is not possible to pass the subtask 2 with the help of only this case. This case you will be able to pass the subtask 1 and you will be scoring the partial marking, but for solving the complete question we will need some optimized approach, and optimized approach will require a pattern, and to observe that pattern we should look this loop too closely, that what we are changing, and why I was saying that replace with x, the only replace with the same value only. So let's think on that, and let's look the optimal approach. So the logic for optimal approach is, efficient approach is, that we will get the nearest index to p. Suppose if this is the array, and here p is equals to 3. If this is the p, and value of x is equal to 12. So in array, we will get the nearest index of that value which is having same value as x. So here two values are present. Here the index are here, it is 1, it is 2. I'm taking one index base. So 4, 5 and 6. So which is nearest, 5 or 6? 5 is nearest. So we want to get this 5 as the value, as the index. So this is what the catch here. This is what the, so this will be the, this will not the complete answer. There are some modifications, some little bit more modification that we have to do. But there are some more cases that we have to see. One more case, that if the value of x is not previously, if it is not present, it is not initially, it is not given in the array. So what we will do? So firstly, we will check the algorithm that we can make here. That firstly we can simply run a loop. We can run a loop from for 0 to n. We can go from 0 to n, and from 0 to n we can check that if value of array, if the value of that a of I is equals to x, if it is equals to x, and what will be the near, how can we calculate the nearest index? If we are getting the difference, if we are here, you can see that 3 minus 5, 5 minus 3 2, 5 6 minus 3 is 3. So which is smaller? 5 minus 3 is smaller. So we can get that absolute of, that is absolute of p minus x, because it is not mandatory that x will be greater or p will be greater. It can be their case then where x is here, x is second value, or x is fifth value. So we will take the absolute of p minus x, and we will store, if absolute is less than min, and initially we will store in min, we can store the max value. We can store the max value of integer, that is something about 2756. That is very big value, so it will be definitely smaller than this. So, and we can get the, we can then replace it with min is equal to p abs of p minus x. And in some integer, suppose we are taking an integer d, and in some integer we can allot this index, so to keep a track of the index, because ultimately we want that index, that index is important to us. So this is how we can, this how the first approach, when there is no k, so how we can get to know that there is no x present here? How we can get, if we can check that if A of D is not equal to X, then what we will do? If A of D is not equal to X, if A of D is not equal to X, then we will sort the array. We can update the value, because we have to then perform the operation. Sorry, K minus 1 I have written here. I'm taking one base indexing. So A of K equals to X. What next we were doing in brute force? It is simple. We were just sorting that. We were just sorting. We will just sort that. And we will also increment the count. Suppose we have taken, and after doing this, we will again check. We will check once that is we are getting that if A of P minus 1 is getting, if we are able to get the value as equals to, sorry, again I have written this P. A of P is equals to X. If we are able, we will simply print the count. We will simply print the value of count. Else there is no require. And there is one more benefit of this in this condition. A of D not equal to X. If it is equal to X, then there will be no increment in count. And initially we are checking this condition that when the case is 0, when the answer will be 0. So we have already dealt with the conditions of that when case will be 0 and negative, and there will be no answer possible. We will reach till here only when the answer is possible and answer is not equal to 0. So after reaching this position that A of P is equal to X, we will print the count. But what if A of P is not equal? What if I have told you everything, the whole algorithm. I have told you that what if we will first calculate the f's of P minus X, and we will store the min, and we will get the D is equal to I, that is the value. So what is the we will keep the track of the nearest index. Now how can we use it? How can we use this value and get the answer? Now only we have to perform only one line. Only there is only one line to write this. Just think on it, that one line will be our answer. That one formula will be our answer. And I have told you that formula. Okay. So the value will be the abs of the answer will be absolute of your P minus X. We will again perform this array, because if P is not equal to X, then we have to again perform this loop. We will again perform this loop. I will also show you the implementation, and again I will tell you that why we are writing this again. That we will, because if P is not equal to X, then again we have to perform and get the nearest element. And at most we will do this only one time. In one time we can get the answer. So we will perform this value again, and P minus X, sorry, P minus D. P minus D. And if by chance we are increasing the count here, then we will add this count also. This will be our answer. This will be our answer. I am taking here one base indexing. That's why I am not adding one here. Because I am taking here one base indexing. If we will take 0 base indexing, then we will have to add one here. So this will be our answer. So this was the main question. This was the main logic behind this question. Thus, it was same as the optimal approach. Only the thing which was required to observe the pattern in the question, just to write 5 to 6 test cases and by yourself and check the nearest element and try to put this formula, you will ultimately get the solution and you will be able to do this question. It is the basic question. It can be done if we are able to write 4 to 5 test cases, then we will be able to do. If not able to get the optimal, then we can always obviously get the brute force approach, and through this we can get the this nearest one approach. Through this we can get that only we have to replace from X only. Now let's see the implementation of this question. So here is the implementation. In the implementation, I am taking here this in input only, NXPK. I am taking the input of NXPK. And firstly, as I was saying that it is not mandatory that array will be sorted. So we will first sort the array. So here we are sorting the array. And firstly, I have told you this. Firstly, we will check this condition, that is A of P minus equal to X. Yes, it is equal to X. Then we will print 0. And then we will continue. That is, we will check for another test case. Now we will check for the cases which will give where the answer is not possible. We will print -1. So if P is less than K and A of P minus 1, yeah, I have written P minus 1 because I have taken 0 base indexing. As we all know that arrays start from 0. So if we are taking 0 base indexing, so we will write A of P minus n. is less than x, and we will print -1. Similarly goes for this case. P is greater than k and a of p minus 1 is greater than x, we will print -1. Now again, now here, now let's not look this for the few time. Yeah, I have written you for this case for optimal approach. I have written you again, and for this case, where optimal approach is for, I have also written the brute force approach for you all. That the earlier which I told you, that while c is less than n, we will perform at most while c is less than n. Why c is less than n? Because after performing till c is less than n, every value will be equal to x only, and we have negated that case where answer is not possible. Here answer will be k. The question will, the program will reach here only when the answer is possible. So here only we will do the a of k minus equal to x repeatedly, and we will sort that, and we will also increment the count, the number of operation we are performing, and if it is equal to x, we will simply break it and print the count. But it will not pass our optimal approach. That is, it will run only when n is less than 1000. When n is greater than 1000, it will fail. So for those cases, we will check that, we will firstly calculate the nearest element which is having value as equal to x. If it is not present, if a of d is not equal to x, then we will simply increment the count, and we will do the same proceeding that we have done in brute force approach. And what we will do, we will simply check again that is a of p minus 1 equals to x. If it is so, we will print the count, and we will check for another test case. If it is not so, then we will again get the nearest element. This thing we are doing only to know that whether the value of x is present already in the array or not. If it is present, we will get the value of that d. If it is not present, then we will simply, because then we will simply check this loop again, and we will get the value of d, and we will simply print the p minus d plus 1. That formula I have told you, that will be our answer. P minus d here plus 1 because I have taken 0 place in this case, and plus c will be, if we have increases the count here, then that also will be get added here. So this was the implementation as well as the explanation of this whole question. I hope you would have been able to understand this question. Thank you.